Hello, today we're going to do an example of modular programming from Dr. Palmer's Lecture 5. And here's the prompt. Suppose you want to take the average of a group of numbers. However, your data is unique, so you want to average your numbers throwing out the highest and lowest values. So the goal of our program will be to sum up all the values and subtract the largest and smallest two values, and then finally create a new sum and a new average. And here's how we'll do that. So first, we're going to open Excel, and we're going to start by doing numbers entered. So we'll do numbers, sorry, it's all in caps, numbers entered, and numbers summed. Okay? And then the numbers we're going to enter will be 2, 4, 6, 8, 10, 12, 200, 5, 6, and 7. So next, we want to find the minimum of the data. So type in equals min, select our data, hit enter. Next, we want the maximum. So we do enter max. There we get 200. And then finally, we want the average. So we do equals average. And then select our data, hit enter. Okay, and once we have this, we want to mark these. So we'll say min, max, and average. Next, we want to define this as the values we retain from Excel. And this will be the values we get from our program, which we will be calling my average. And now next, you can see I'm going to click between B and C, double click, just so that I can fit my average into the cell. So once you have this inputted, we want to go into Visual Basic. So you go to Developer, and then click on Visual Basic. Once here, we want to go to Insert, Module, and this opens a new module where we will be typing our code. So like what you want to do with every code you want to make it yours and personalize it. So you want to do single quote, then to your name and the date. And now you're ready to start writing your code. So we're going to define our subroutine. So we'll call it sub my average. Hit enter, and Visual Basic creates your subroutine for you. Next, we want to do a new function called dim. We're going to do t and 10. So this is basically saying that we have 10 variables that we're defining, and they will come from these 10 numbers, and they would create these 10 outputs. This is predefined for your entire program, so that you don't have to do it for every sub process. So next, we're going to do our input data. So input data. We'll do sheets to select the sheet. So it's going to be sheet 1 dot select. Next, we want to select our range. We're going to start in cell A4 dot select. Then we're going to define NT equal to 10. And now we're going to start our for loop. So we'll do for I equals 1 to NT, T sub I equals active cell dot value. Next I. So this is basically saying that we're going to start at I equals 1, and we're going to go to I equals 10, because NT equals 10. And TI will be our active cell value. And that next I will just repeat the loop for us until our loop is complete. So next, we'll define our output. So we'll do range, and then we'll put that in cell B4, which is right next to A4. Dot select. Okay, and now we'll start our sum. So we'll want to set our initial sum to 0. So we'll say sum equals 0. And then we'll start another for loop. So we'll do for I equals 1 to nt. And then we'll create the next sum. So sum will equal the original defined sum, which in this case was 0, plus t of I. We'll do active cell equals sum. This is basically saying that once we've done our first sum, which will be sum equals 0 plus our first ti, we'll call the next cell sum, so that once the loop repeats, this value created now becomes the active value, and we can add another value to it to continue our summation. So we want to do active cell offset, active cell dot offset, and then here it gives you the prompt. You can see row offset, column offset. We just want to move down 1 row and 0 columns. This will just help us organize our data so that each new data piece goes down one row. So dot select, and then we'll do next I to continue the loop. So next, we want to define our minimum value. So we'll say minimum, and we'll make it equal to some value that we know it can never be. So we'll call it 100,000. And then we'll start another for loop. So for I equals 1 to nt. And then we'll start an if-then statement. So we'll say if t of I is less than or equal to the minimum, then minimum equals ti. This is basically saying we're setting our minimum at an unrealistic value for our data set, and that the program is going to search for a new minimum, the ti, and if that minimum is less than or equal to the previous minimum, then we've found our new minimum. And it'll continue looping through that until we found the absolute minimum of the data set. So next we want to do next I, and that'll continue the loop. And then once the program's found it, we do active cell dot offset. And again, we're moving down 1 row and no columns. Dot select. And we'll say the active cell now equals the minimum. Okay. So next we want to do another offset. So we do active cell dot offset. It will move down 1 row and no columns. Dot select. And now once doing this, we can find our maximum. So we'll do maximum equals another unrealistic value for our data set will be negative 100,000. So we'll use that. And we'll start our for loop, just like we did for the minimum. So say for I equals 1 to nt. And then our if statement, if ti is greater than or equal to maximum, then maximum equals t of I. And again, we'll do next I. So the program knows to continue searching for our maximum until it finds the absolute maximum of the data. And then once it's found that, we'll define it as the active cell value. So say active cell equals maximum. Okay. So now that we've identified our minimum and maximum, we can find our new sum. So we'll define new sum equals sum minus minimum plus maximum. Now with our new sum, we can find the new average. So we define new average equals the new sum divided by our total number of data points, nt, minus 2, because we've eliminated the minimum and maximum of our original data set. So we hit enter. Now we do active cell dot offset, and do down one row over no columns dot select, and we can input the new active cell for the new average. So active cell equals new average. And that completes our program. So now, since we've already inputted the data, as you can see here in our Excel spreadsheet, you could simply run the program by pushing this button up here. But we're not going to do that. We're going to again go back to the Excel spreadsheet, go to Insert at the top here, Button, and then we're again just going to create a button for ourselves so we can run the program from our Excel spreadsheet instead of having to click back and forth. So we want to assign it to our subroutine myAverage. So click on myAverage, click OK, and then we have our button. And again, you can click inside the button, and I'm going to give it the name Run, because it makes our program run. So click outside of it, then click Run. And as you can see, we get our values. However, there seems to be a little error. So we should go back into our code and see where the error could be. Up here, we forgot to offset the cells. So we need to do active cell dot offset one row, no columns, dot select. Now this is important because when we go back to our spreadsheet, now our program will run linearly. Before, we missed one cell, so all of our values got thrown off. So now we click Run, and you can see the program runs normally. So you can see here we have our initial output is the initial sum we called 0 plus our first value. So we get 2, and then the next cell we get 2 plus 4 is 6, 6 plus 6 is 12, and then 12 plus 8 is 20, and so on. And we get our minimum and our maximum of our data, and then the average. Now this is very handy to have this Run button here because you can change the data. So we'll change the 200 to 100. Click Run, and you can see the value of the max changes to 100. However, our average for the myAverage does not change because the minimum and maximum are taken out. And so that's the end of our program. Thank you very much.